and share my screen. Okay, so what we're going to do is go back to session 3 and then look at session 4. We actually skipped ahead to session 5 with Ronnie yesterday, but we're going back to session 3. So just to remind everybody, in session 3, what we were looking at was an exercise to try and map the MIBs for a camera. And basically, we parsed the MIB, as you will remember, into a configuration file. And we downloaded that file, and then we started working on that file to try and add in any additional information in order to be able to turn it into alarms and actually manage all of the fields. And you remember that I left you, we basically started on this exercise, which was essentially basically starting with that file, checking that we can send events, and then identify how we can raise and clear traps using var binds. And as you remember, we put in the var bind in order to determine which particular trap we were worried about, whether it was the raise trap or the clear trap. We also needed to set a severity. And we created a raise and clears. And then we needed to get on to adding the reduction key and the alarm clear key in order to be able to deal with those alarms. Okay, so what I'm going to do is, I really do want you to finish this exercise, and we'll try and do that in class. We'll spend the first half hour or so doing that. So have people got the work that they were working on last time? If I put you into groups, can you carry on with that work? Would that be okay?
Sure. Sure.
You're all very quiet today. You're like, as students at the university, it's impossible to get them to say anything. So thanks for all right.
Not worry, Craig. This is because we only took one coffee. We need the second one, I think.
Right. Good. You've got the opportunity. Okay. So let me put you into groups again, and then you can just carry on with this exercise for half an hour and see how we get on, and I'll work my way around the groups. So
one thing, Craig, and
sure.
I apologize in advance, but today, unfortunately, I have to go to the funerals of my aunt, and so I will have to leave at 11, so 1 hour before ending this session. So sorry for that in advance.
Oh well, it's okay. Eric, condolences on that, and
thanks.
Obviously, it will be recorded, so
I will. Yeah, I will listen. I will listen after. Yes. Okay.
Okay. So I'm going to put you into 4 groups. Okay, so I'm going to start. Okay, so you've all struggled to do this under greater or lesser success. So I'm going to talk through what the process should be now, okay? So first thing is, let's look at the example traps. And we can see here that I provided example traps for palm motor raise, palm motor clear, and various other things, okay? Now, the thing is that, bear with me, I'm just going to stop that phone. Hang on. Sorry about that. Right. Okay, so for each of these traps, we need to create a separate event or a separate alarm, okay? And that's what the exercise in the configuration was. Now, we saw that we had a selection of MIBs that we parsed in. So if we go back to SNMP Sim and we look at the MIBs, you can see we pulled in all of these MIBs and we parsed this Chubb TVBS camera MIB. And what that gave us was 2 configuration files. The 2 configuration files are in this events generated from MIB, okay? And the first one was eventconf.xml. And all that does is it tells us where the other file is going to be. If you don't include that file reference in eventconf.xml, OpenNMS will not know anything about it.
Yeah.
So it's going to look in the events folder, and it's going to look for this file here, Chubb DVBS camera MIB.
Yeah.
Now, if you actually look at what was generated, this is the actual file that was generated, okay? And you can see that it's got the OID of the trap, generic and specific values. That's just standard stuff. And it's also generated an EUI for every one of these problems, okay? Pan motor, tilt motor, zoom motor, or whatever. So we've got, UEI, health change, and we go down and we can see that, we've got another one here, temper detected.
One question.
Yes?
One question, if I can. If you go up, please. When you say, for example, mask element and name generic and values is 6, what is referred to here? What is generic and 6? For example, mask element, I think that you can nest all this topic, whatever you want, but how do we, where do I take generic?
These come from the MIB, okay?
Oh, okay.
So the OID and the generic, these are just a way to understand the trap, okay? So the MIB's been parsed and that's what these come from, okay?
Yeah.
A generic trap, basically 6 means it's an enterprise trap, which means that it's a trap specific to a company, okay?
Okay.
Right? And specific is just another number that's given to the trap. The specific could have different values, okay? So every trap will have an OID and a generic and specific value.
Okay, so
it's given to us by the MIB.
Whatever is the trap I define, I have always to put generic and specific with 6 and 1. Is it correct?
No. It'll be defined for you whenever you parse the MIB.
Okay.
Yeah, it will be automatically dumped after the compilation of the MIB. This is what you mean?
Yes.
Okay.
Oh, okay. So I don't care about this. I mean, I will find it.
We just care about the varbind.
But you don't need to worry about where it comes from. It'll be generated for you.
Okay, perfect.
All right. Sometimes the specific will be different values for the specific, okay? But that will come from the MIB. Whenever you parse the MIB, it will generate that for you.
Okay. Perfect.
Anything else?
So yeah, so we need to focus on the varbinds, if I well understand, Craig.
Yes.
So typically, if I want to map correctly the field of the trap. So let's say I want to map correctly what we have below here: pan motor, tilt motor, zoom motor. Which varbind shall I?
I'm going to come on to that.
Okay.
Right. Okay. So we have only got 4 traps defined here. Okay.
Okay.
But for each of these traps, the varbinds will determine more than one type of event. So we've got 12 different events here we could have. And because we're also going to have a raising event and a clearing event, then we'll actually have 24 different events to worry about. But we start off with 4 generic events. And I'm just going to worry about the first one for now. Okay?
So
this first event,
do I understand correctly that with current configuration, we will have 20 events which will be correlated to four types?
No, what we have is 4 different types of trap that can come from the equipment.
Yeah, but if we have 4 different UAIs, it would be like only 4 different possible ways to correlate them, right? And this is what we should configure.
No, I'm not got there yet.
Okay.
This is what you get, okay? Whenever you compile the MIB, 4 different types of trap. We need to do more work now to look at the var binds to work out what the trap means. Okay? So that's what you get when you parse the MIB. Now, under simple alarms from the MIB, I've done 2 examples. This is a simple way to do it, and then there's a more complex way to do it. We'll start with the simple way, because simple is easier. Here, what I've done is I have added in the second var bind, okay? If we go back to the traps, okay, you remember that the first var bind, basically see integer 0, gives you pan motor raise. Integer 1 here gives you tilt motor raise. And integer 2 here gives you zoom motor raise. Okay? So the second var bind is the one we're interested in. It's either going to be 0, 1, 2, 3. And then the third var bind, sorry, I got this wrong, sorry. The first var bind, the second, because the first, this is actually just the OID. So the first var bind we're interested in is the value. The second var bind is it raise or clear? So you can see it when it's a 1, it's a raise. When it's a 0, it's a clear. 1 raise, 0 clear, 1 raise, 0 clear. Okay?
Okay.
So in this case, what we're going to do is we're going to create a health change raise. Okay? And we're looking at var bind number 2.
Mm-hmm.
And if it's a 1, it's a raise. If it's a 0, it's a clear. Okay, so that var bind 2, we got a raise. And further down, this var bind 0, it's a clear. So this is a health change event. And
so
we as
var bind value 1 is a raise, 0 is a clear. Okay, because var bind number is always 2. Like in both cases. Okay.
We had a different var bind number. Well, the var bind number will always be 2 in this case. That's correct.
Okay.
All right. So raise and clear.
Yeah.
Right. How do we determine the var bind 2? The var bind 2 is given by the SNMP trap input parameters?
Yes.
Okay.
Yeah. So we just need to know, that what you'd have to do is look at the trap and see what the values are in the trap. And we just know that. I've given you that. Okay.
Yeah. And read carefully the MIB and
exactly. Yeah. Or import the MIB into that MIB browser, and that will actually give you a definition of the trap. It'll be easier for you to work out what's in the trap that way.
Okay.
Okay. I mean, I can show you that. If we just go to the MIB browser. There we are. So these are notifications. So these are the actual notifications. Okay. Health change, right? So if we look, that's the trap, right? That's going to come out. So the health change trap. If we look at the definition of that, you can see it's got 2 objects. The first one is the health change reason, and the second one is the fault state. Yeah. So the first var bind will be the reason, and the reason will have, you know, these various values, you know, pan motor, tilt motor, zoom motor, etc. Okay. So that's how you would look at, if you looked at the MIB browser, that would make it easier for you to understand what's going on. Okay. We're looking at the health change trap. So we're looking at the first varbind is the reason, the second varbind is the state. Now we have a choice. We can create a separate event for every one of these health change events. So we'd have an event for each of these pan motor, tilt motors, or whatever. But what we're actually going to do is just, in this case, simply create one health change event. And we'll use the varbind decoding to actually tell us what the event means. So, you know, parameter 1 is going to tell us, is it pan motor, tilt motor, zoom motor, or whatever. And we can use that in the text. Okay. So if we receive this particular event, the event definition, if you look at the log message, it's going to say health change trap received, health change reason parameter 1. It's going to translate parameter 1. So it's going to tell us health change reason, pan motor, tilt motor, zoom motor. So we'll get text in the log message. It tells us what the problem is based on that first varbind. And in this case, we don't need to create more than 2 events in OpenNMS because the event definition will basically give us all the information we need depending on those different varbinds, okay? And then the state parameter 2 is either going to be clear or triggered. So when we look at the log message, we'll see, you know, health change trap received, change reason equals pan motor triggered, and we've got a problem, or cleared, and we've cleared, okay? So all we need to do is create an event for the raise, which is the varbind 2 as a 1, so health change raise, and then we create an event for the clear, health change clear, which is using the 1. We don't need to worry about the other varbind because the other varbind will be decoded in the message. Okay. Now, what we do need to do, however, is we need to set the severity. So in the raise situation, we're going to set the severity as warning. Now, if we do the decoding this way, we can only ever have one severity for all of these. So each of these may have a different importance to us, but the reality is if we decode the events in a simple way like this, we can only give all of these the same severity. So they're all going to be, if the pan motor goes wrong, we'll have a warning. If the video signal goes wrong, we'll have a warning. They'll all just be warning, okay? And similarly, further down, if we receive a you know, if we look at that again, yeah, the clear varbind, then we're just going to set that severity to normal. So we'll either have an event coming in saying severity of warning, which means that we've raised the problem, or we'll have a event coming in with severity of normal, which means the problem has gone away. So those are the 2 events. Okay. Now, what we then want to do is we want to set up the reduction key so that every time an event comes in, we'll only ever get 1 alarm. And we can see here that the alarm data reduction key, what we've done is we've taken the UEI, the DP name, which basically just corresponds to Dominion, the node ID, which clearly is this particular, you know, whatever node we've got, and then the parameter. Now this is the difference. If you put parameter 1 in that reduction key, you will get a different alarm for every one of these values in the trap.
Okay.
So I can still have a zoom motor alarm, which will be a warning. And at the same time, I can have a wiper motor alarm, which would be a warning. And at the same time, I could have a washer motor fault, which would be a warning. It's 3 separate alarms. And if those events come in with the same values again, then we'll not get any more alarms. We'll just get an increase in the alarm count.
Okay.
And this works because we've included the parameter as part of the reduction key. Does that make sense? Anybody want to ask a question on that?
So the event is generically one, specified but all the verbine values, right? And then you can, actually proceed in specifying with the alarm part with the specific verbine, differentiate the event in alarms in such way.
So in this case, we are creating multiple alarms, but the way the alarms are separated is by the second parameter. Okay. So that reduction key is going to have a value pan motor, tilt motor, zoom motor, depending on what the actual parameter was that came in.
So each pan motor will be correlated with clearance for a pan motor, right?
We haven't got to the clear yet. We've just got, all we're doing is creating the
different alarms.
Reduction means the correlation.
Reduction key, yes. So the reduction key means that if this event comes in, if the same event comes in from the same node, then we don't generate a new alarm. We just increase the alarm count. The count of the events in the alarm.
So, for example, we have pan model and motor, and next will be zoom motor. We will have 2 alarms.
Yes.
If it's not closed in advance, yes, always the same alarm. If it's being closed, it's a new alarm, correct?
That's correct.
Okay.
So if the alarm has gone away.
Okay. What about auto clean false? What is this? Auto clean false.
Auto clean will basically get rid of all of the events other than the latest event. So if you don't want a buildup of events in your system, if you make auto clean true, then every time a new event comes in, the old events are deleted.
A new event related to the same kind of event.
Same alarm, yes.
Same alarm.
So you'll always have the latest event associated with that alarm, but you won't have all
which is the practice you suggest? I think that you have to balance, because
false.
False.
Just leave it false. That's what I suggest. Okay.
And so the maintenance of database has to be done with a policy that is.
We're not going to talk about that now, but we'll just not go there. Okay.
Okay.
Right. So false basically means that we keep all of the events. That's fine. Yes. Sorry. Yes, please.
Yeah. Can we see reduction key in the alarm browser or in some log files?
Yes.
For troubleshooting
in the alarm in the browser. When you look at the alarm, you'll see the reduction key.
Okay, thanks.
Right. But it's just there for information. You don't use it, generally speaking. Right. So that's the raise. Now remember, the clear, what we want to do is for a clear coming in. So in this case, the clear, if we look at that, verbine number 2 is 0. So it's a clear, have changed clear. And what we want to do is, first of all, we have a reduction key here, which is exactly the same as before. But the idea is you may have more than one clear event coming in. So you want to deduplicate those events into a single clear alarm. So that's why that reduction key is there. It just prevents you having multiple clear alarms when you don't need them. But this is alarm type 2. And the clear key is telling us that when we have a raise alarm, that's the one that was further up, then if this clear key matches and the parameter matches, then this particular event here is going to clear that matching raise.
Okay, but sorry, UAE that you specified explicitly here is not the same of the previous macro,
so that,
UAE.
Okay, so that UEI there is the same UEI as you have on the alarm raise. That UEI. So it's telling us that we're going to clear that particular event on that particular node. right? So when the clear event comes in, so the clear event will be decoded into alarm change clear. It'll be deduplicated into a clear event. And then what will happen is it will look for that raise alarm on that node with that parameter, and it will delete it or clear it.
Okay.
Does that make sense? Any questions? This is important to get right. So if there's any doubt in your mind, let's make sure that we.
What is the DP name here?
The DP name is it's distributed polar name, and it basically corresponds to the minion. Okay, and it's just another way of identifying that node ID on that minion. If there's no minion, there won't be any DP name, but that's fine. Just leave it in there. Now, I'll be completely accurate and say, actually, this DP name isn't really used anymore in OpenNMS. It's left there for historical reasons, but it doesn't actually make any difference. But that's what it was. It was for identifying the distributed polar or the minion.
The node ID corresponds to the node which we created in the UI, right?
Yes. So whenever a node is created, it's assigned an ID in the database. And whenever an alarm or event comes in, the trap comes in, the trap gets generated with the node ID that corresponds to that node. So this is saying that if a trap comes in for that same node with that same parameter, then we want to clear it. Okay, so that that was a simple approach, right? Which the problem with the advantage of the simple approach is that you only need to define 2 events, because all the extra information is just going to be generated in the text, but you'll only ever have 2 events. The problem with it is you can only assign the same severity to all of the events that you've got in here, and that may not be useful because you know, house temper may be more important than washer motor fault, okay? Or camera comms fault may be much more important than washer motor fault. So
yeah, does it mean, can I assign a different severity
not this way.
That's the problem, okay.
Not this way. That's what I'm going to go on to next, okay?
Okay.
Right, so the only way to assign a separate severity is to create a separate event for each of these values.
Okay.
Instead of one event and using the alarm function key.
Okay.
Yeah. So that's what this second example is. Full alarms from MIB. Okay. So in this case, it's very similar to before, but the difference is that I am adding in varbind 1, which remember corresponds to pan motor, tilt motor, hill heater, or whatever. So varbind 1, value 0, will be pan motor. Okay, so I've added an extra bit onto my UEI. And if I go down, then I will have health change trap, pan motor, health change trap clear. This is all the same except that that's a 0 and that's pan motor clear. And then I'll go down to the next one, which is tilt motor. And in this case, I've got the varbind 1 as value 1. That's a tilt motor. And so on down, tilt motor clear. And so on and so forth, okay? So in this case, we actually have to define 24 separate events. But each event can have its own severity. So you can see that in this case, further up, that was warning. But if I just dump down a little bit, I think we'll have one that's got a different severity. I've probably got one that's critical somewhere. I'm not sure exactly where it is. Yeah, warning. So I have changed the severity on some of these. I think the door opening one, I will have a different severity for. Well, the point is also that you can actually change the description for each of these as well. So at this point, we've just got a very generic description that's just been generated for us. But that may not be what you want to show to your operator. You may want to change this description completely into something much more meaningful for each of these different events, to tell the operator what they want to do or to explain what it means. And you can have a different description for every event, as well as a different severity. Okay. Now, again, the reduction key is slightly different. The reduction key is the same here, but I've left out the parameter. That's very, very important, okay? You don't need the parameter in the reduction key anymore, because the parameter is now being decoded as part of this var bind. So that's left out. And, we go down to the clear, and you can see exactly the same in the clear. We've left out the var bind, but the clear is actually the same. So that's a pan motor clear DP name node ID, just so you can identifies it. And the reduction key, there's no var bind. Does that make sense?
So basically, the difference is that here we have our parameter coming like a part of UAI, right?
Yes. So we have a separate UEI generated for each of these different values. Whereas in the other example, there's only one UEI generated, and that's these values just go in the text of the log message.
Yeah. Okay.
We don't have different UEIs. Now, there were traps in here that, if I go right down to the bottom, that com state change, that's fine. Com state change, let's see, it's this one here. Logic input change. Now, in this particular example, logic input change actually had var binds that changed depending on the logic input information. So if I just go back to the example traps, just make sure I'm doing the right thing. In the example traps, logic input change, we've got, in this case, we've got the logic input OID and the logic input state. Now, in this case, the logic input is a value that's been given to us. So it's basically saying that there is some sort of dry contact on the camera. Perhaps it's to do with security alert or door opening or power or something like that. And that value will either go to 1 or to 0, depending on whether the electricity is applied to the contact or not. In this case, we don't know what the values of the logic input are. So what we've done is we've just used the previous method for the logic input change, rather than trying to decode it completely, because we can't. We don't know enough information. So we go back to where we were at before. Let me see. Yeah, logic input change. Let's go and see it where it is. Yeah, you see logic input change. That logic input change is just using the same method as previously, where we've got the parameter as part of the alarm reduction key. And it's doing that because it's basically going to tell us what the logic input is, and that'll be a value. We don't know what the value will be, but it'll come in from the trap. And I'll just include it in the log message as before. But we'll get a raise and we get a clear. We just don't know what that value means. So we can't decode it. We just use this simple method here for logic input. But for the ones that we do know, these door opening and whatever, then we can decode it completely. The decision on how you decode and what you want to do is basically down to you. You know, once you understand the traps that are going to come in from the device And once you understand the business meaning of those traps, then you can start changing how the traps are dealt with, what the severity of the alarm is, what the message is to the user, depending on the information that you have.
Yeah, I also see a third way to do. You can group by severity the traps for the types. You
how would you group by severity?
Instead to create 24, you can create like a small group, like first.
You couldn't do that because the var bind is the way in which you determine the UEI. So you would only ever have one var bind. You couldn't sort of say, well, for this range of var binds, we'll do that, and for that range of var binds, we'll do this. You've got to do it for each different value of the var bind.
But var bind ranges could be a nice feature of the product. Patterns.
They would be a nice feature of the product.
Yeah.
Aren't feature of the product.
Yeah.
Now, I will say,
next week you will have a pull request.
Yeah.
Now you have a new request for change.
Yes.
Enhancement one.
I will say, actually, now I haven't checked this, so you need to go and check the docs, but it may well be possible to put a regex in the var bind. Okay, regular expression, which would give you the ability to select on a number of values potentially of that var bind value.
But on which point? Not here, I guess. Not in.
Yes, in var bind value, you could put a regular expression in there. Okay, so you could select on that value several different values. If the var bind matches, then you'll get a match.
Yeah, because in reality, sometimes you are receiving traps with several hundreds of the possible var bind values.
Yes.
And no,
that's why life's difficult.
And by the way,
really two ways of dealing with this, right? One is to decode all of the values, or perhaps you can, create something that will be simpler than that, but you won't get the generic. So yes. Now the thing I'll say is that, this is why people over many years have contributed these configurations back, because it's a lot of work, a new device, new set of traps to worry about. If you've done the work and you've decoded and it's a good configuration, then if you contribute it back into the project, then it stays with the project and other people can benefit from it. And, as the project gets updated, your configuration will continue to work. So, we do strongly encourage people, there is a lot of work to making this stuff, to doing these configurations. If you do them, you can keep them to yourself if you wish, that's your choice. But it would be a good community citizen that contributed them back, because that's how we build up a richer and richer set of traps for different types of devices.
But do I understand correctly that in any case, we will have all the traps coming from equipment on our events, and this configuration is only done to create like a separate set of alarms based on those traps?
And also to decode the trap itself into meaningful information.
Yeah.
So if you remember, if you just get a trap, which we can't decode, we just get a generic message that says we've received a trap, and it doesn't tell you anything other than the value of var binds in the trap. So if you get a trap, you will always get a message of some sort, but it won't be very useful. And this exercise is about making those messages human readable, so that a human can see, what does this mean? How important is this? Do I need to deal with it now? And if I do need to deal with it, what does it actually mean? That information is not in a generic trap. It'll just tell you this is a trap for this OID, came in from this device. Don't know what it means, but it's come anyway. Could be really important, may not be important at all. No idea.
One question: if I'll make a mistake in XML file, for example, and file will be corrupted, will only this file not be loaded into trap D, or entire trap D will fail?
The entire trap D will fail.
Oh.
So it has to be cracked.
Craig, will we have any, at least short session of troubleshooting things which could go wrong here?
We did that off the first hour. Every possible thing went wrong. Yeah.
I mean, we're supposed to support this product
I know,
because
I
it's
understand.
sold like part of our solution. So.
Yes, I agree. I mean, to be honest, I obviously the problem is there's so many different things that can go wrong. It's easier to show you how to do it right than to show you what would happen. The reality is that if the XML, when OpenNMS starts up, if the XML files are not formatted correctly, then OpenNMS will fail to start. If you reload the event daemon using the event that I showed you the other day, so you're actually just reloading the file rather than restarting OpenNMS, then it will tell you it failed to load or it did load. And if it failed to load, then it'll probably tell you in the message what the problem is. But the other place you will want to look at is the logs. Okay, so this would not be a good example.
I mean, we're having many moving parts here, many
yes, you are.
containers running in Docker. Is there any tool which could, for example, like collect all the needed information in case of the problem from all the containers running? No?
Nope.
Okay.
No. I mean, there are logging tools you can use to get the logs all in one place and have a look at that. That's clearly possible. But the reality is you need to understand the logs themselves and work out. So let me just look at the logs. Docker pose. So I'm in the Horizon container now. Mm-hmm. And you'll see that there's a logs file. Okay, so these are the typical logs that you'll see, right? Now, event.d.log is probably where we would see any serious problems if they were happening. So, and there's obviously no problems at the moment, right? But if we reloaded the configuration and it didn't load properly, then you would see a log message here that would tell you what's wrong. And the sort of thing it will tell you is that the MIB didn't parse. The XML didn't parse properly, and it'll point to the point in the file that's got the problem. But again, editing in something like Eclipse, like I'm doing here, is going to make it much easier to make sure you don't get the thing wrong. If you edit an XML file in Eclipse, it'll actually make sure that you're correctly aligned with the XSD, and it'll tell you if there's a problem.
Yeah. And for a Karaf container, is there any tools to check the state of the components, HCI components which are deployed there? Like restart them separately, or it's like easier to restart the container?
Well, I mean, the only container you're really worried about is the Horizon container, and truthfully, you'd be better just to restart the thing. Mm-hmm. The database, is separate, so that's going to be a separate container for Postgres. Again, if the database does get corrupted, there's tools for Postgres to sort out Postgres itself. But I mean, the truth is, very, to be honest, OpenNMS very rarely goes wrong. What happens is that people's configurations are wrong, and the the system will stop working, either because the configuration couldn't load or because the configuration is creating all sorts of errors and the logs have just filled up completely and you've run out of room. That's generally what happens. So, if the worst comes to the worst, restart the Horizon container. But the logs obviously are important to look at if you need to look at them. And again, if you have a Logstash or something like that, if you send those logs to Logstash, and you can do that within the log4j.xml like we see here, you can change that configuration so that you're sending the logs externally. Then that's probably the easiest way to have a record of the log files after the container fails. And again, you'd set up the logging to debug if you need to actually check a configuration. Mostly it's set left to warning, which just tells you if there's a problem.
And do I understand correctly that you told us on the first session that separate parts of the system are monitored by core as well? So we are getting traps from the subsystems.
Yes. Yeah. Well, you don't get traps, but you do monitor the rest of the system. Yeah. So we've got half an hour left, and I want to move on, talk about one other thing today, to introduce a new topic. If we leave these sorts of questions till Friday, then hopefully on Friday we can sort of wrap up and deal with any sort of outstanding issues. This is a basic introduction. We do more comprehensive training on debugging OpenNMS or triaging problems in OpenNMS. That's a separate session to any of the stuff that's here.
Okay, thanks.
Can arrange for that separately, okay? But I can just give you an overview. But the guys who actually do this day in, day out have a set of things that they do to actually find the problems, and they can talk you through that. Okay. So,
Craig, one last thing. Yeah, when we send the traps, right, the first part is the OID, next part is the warbinds, right? How do we get those? Like if I need to send my own traps, like in the example traps you have mentioned some.
Yeah. So, okay, so these are the example traps. So you just use SNMP trap and send that's basically the format for sending the OIDs.
Yeah, where do I get this OID and the warbind values?
Browser.
Well, you need to, that's what I showed you the MIB browser for, okay? So if you load the MIBs into something like MIB browser, it'll actually allow you to see what the traps are. So these are the traps here, the TVBS notification prefix. So it's 4 different traps. And you can see health change trap. And they've got the objects here, health change reason and false state. So those are the two warbinds. And if we look at health change reason, look at the definition for that, you can see it's got a number of values here defined in the MIB. So health change reason will be, 0 to 12. So that tells you how the trap is constructed. Okay. But if you want to use this browser, then there are tools for sending traps here. So trap sender, and you can specify that, I want to send enter my specific trap, and you put in the OID and you put in the values as the warbinds, and you can send the trap that way from this tool. Other tools are available. Or if you use SNMP trap, which is part of NetSNMP, then you can send it. And in this case, you give it this is the OID of the actual trap itself. And then these OIDs are the values. So this is varbind 1, integer, varbind 2, integer. So that's it, really. Other than that, you'll just have to, based on the MIB, load the MIB into a system that enables you to see them properly, and then you can work out what the traps are.
Thank you. Got it.
It takes practice. It is a little confusing at the beginning, but ultimately you get, the first thing I tend to do is try and work out what traps are going to be there, and then I'll try and create these little configurations that I can use for tests. Once I've done that, then I can start creating the configuration for OpenNMS itself. Right, no more questions. I want to move on and talk about one other thing that's important. Okay. What do we do if we don't have all of the information that we need? Now, in session 4, which to be brutally honest, we haven't got onto at all in this exercise, this is the exercise, okay? Imagine that multiple cameras from the examples in session 3 are controlled from a single camera controller. So we've got loads of cameras out along the motorway, and we've got a single camera controller which controls them all. Now, the camera controller is going to send us the traps. Okay? The cameras themselves, we cannot see. But we do want to associate the messages from the camera controller with real cameras that are out in the field. So if I go to my OpenNMS, I have loaded up a configuration already into my OpenNMS. And this is from exercise 4. If I look at the provisioning requisitions, you can see I've got these camera locations. And I'm just going to look at the thing, and I've got camera 0, 1, 0, 2, whatever, okay? And I have asset information against that, which basically says the latitude and longitude of each of the cameras. I don't have any interfaces against these cameras because these are not real nodes that OpenNMS is monitoring. These are just ways for us to tag an alarm against a real location. Now, if I look at a map, geographical map, we can see that on this map, I've got 2 cameras here. I zoom in, you'll see that actually, I have to zoom in a bit, actually 1 camera there, 1 camera there, and other cameras in other locations, 4 cameras here. Some of them have got warnings, some of them not, okay? So that's setting up the system. So we've got nodes in the system that represent these cameras. If you look at the nodes, you can see all of these cameras are here. If I look at one of these cameras, you can see that there's no interfaces associated with it.
Craig, sorry, in order that the maps are able to locate correctly in the maps, the objects is asset the right field? Asset.
You have to set the asset information.
Okay.
Okay.
So the asset information you have to put
the asset information gives you the latitude and longitude of the thing on the map. Okay.
Okay, thank you.
But you're also putting that into the provisioning requisition. So you can see here.
No, yes, of course.
Okay.
But the nodes inventory is the result of this.
Yes, that's right. Okay. So the asset here, latitude and longitude. So that's going to go into the inventory. All right. Okay. Yeah. So the question is, given I have traps coming in from that camera controller, which is a separate node in itself, okay? Here we've got camera controller. How do I translate those into alarms against each of these actual cameras? And to do that, we use something called the Event Translator. Okay. Now, if you look at Event Translator, there's various different configurations that you can do with it. But essentially what it does is it listens for a particular event. It then looks at the values in the event. So it's looking for this particular OID in a parameter. And then it will recreate a new field in that event. In this case, it's the node ID. And in this case, it will reassign a node ID based on the actual var bind. So let me show you what I'm doing in practice here.
Yeah, but here we can change not only to node ID. For example, we can modify severity and other attributes, right?
You can, yes, you can. Unfortunately, what you can't do is change the order of the actual var binds in the original trap, but you can add extra information in. So in exercise 4, right, okay, these are my example traps now for my new camera controller traps, okay? And they are essentially the same as before, but now we have var bind 1 is a camera identifier, okay? And then we've got the help change reason, and then we've got the fault state. So the help change reason and the fault state are exactly the same as before, but we've got an extra var bind in front of everything else, okay, which is camera 008. So what we need to do is we need to look at the value of the first var bind and work out from that which node we need to assign this new event to. So the event will be sent into OpenNMS. We will generate an event within the camera controller, but we need to generate a new event based on that original event that will be assigned to the actual camera 08. Does that make sense? So we do that with this event translator configuration. And just jumping ahead, let me show you the actual event translator file. This is the translator configuration. Now, most of this is what is originally there because OpenNMS uses Event Translator for other purposes, okay? But right down at the bottom of this particular file, these are the translation, okay, that I've added in. Now, what it's going to do is it's going to listen for a pan motor UEI. And then it's going to assign a different node ID. Now, this here example is assigning a constant. It's just never going to send a single thing. But actually, and we haven't gone through the exercise, but in the actual exercise, this is what you would actually do. You would look for the pan motor UEI. When you receive that trap, you'll look for this OID, which is going to give you the name of the node. And the result of that OID basically is going to be used in this query. Select node ID from node where the node label equals the value associated with that var bind. So if the value associated with that var bind is node 8, then it's going to look for node 8 and it's going to give you the node ID of that node.
What about performance stuff for this, Greg? Because every time we have to make a query. Maybe a silly question, but it's not nice.
Not a silly question. There is a cost to doing this.
Okay.
Okay. Because, so, but you know, we do it for. There are events in OpenNMS. I mean, node down events in OpenNMS or do this anyway. So, you know, if we look again back at that event translator. You'll see that you know, for these link down, link up events, what we actually do is we look at the event that's come in from externally. This is a trap that's come in, okay? And we actually do a lookup to find the interface. And what that means then is that we can actually add extra information in to say
this is a basilar trap, because otherwise you don't match to the interface. If you don't do like that, it's important, very, very important. This.
Right. So this is how we use the event translator to enrich the node down and node up events, and it gives us a bit more information about the IF alias and the IF description. Okay. So this runs normally. This is just a standard part of OpenNMS's configuration. This extra stuff down at the bottom is what I'm adding in. Okay. And like I say,
so translator configuration is provided for the most important trap as a built-in feature, or we have always to add here other translations if needed.
Yes, you need add extra translations if needed.
Okay. The previous one are built-in out of the box.
The previous ones are just out of the box.
Okay. Because I make use of that one.
Okay.
Otherwise, we cannot have a link down directed address to the interface, right?
That's fine. Yeah. So anyway, this is how you would do it. Okay. Now, the thing is that you're still going to have a translation spec for every one of these UEIs. So it may actually be using the previous method with the health change UEI and not having a separate UEI pan loader, etc. would be a better approach, because then you only have to have one translation. But you've got to make that trade-off. Either you have all of these UEIs and you've got to translate them all independently, or you've got to have one change, you know, just the health change, and that would be the first example I showed you. Then this will work fine. Okay. So let me show it working, just to finish off this little bit. We've got our cameras with different values here. Okay. And we're going to look at our events. Just look at all the events that are coming in. And if I, so I'm in my camera controller and I'm going to send an event. So I just need to find the event I want to send. And these are the example traps here. So let me, so it was pan motor. And I'm going to send this into the system. And hopefully we will see a new event is arising. Right. Now we actually have, so that's not decoding properly for some reason. There's something not quite right by that. In my example, I don't know why that is. Let me just go back. If it doesn't work this time, well, we'll come back to this on Friday probably. Probably because I'm using the session 3 traps. The session 4 traps have changed. Remember, there's the camera controller traps. So if I use this one, then see if we can get this right. There we go. Okay. Now you'll notice that we do actually have an event against the camera controller, and there's nothing I can do about that. It's just going to be the case. But we've also got this new event against camera 8. It's actually the same thing. So it's a pan motor raise against camera 8, but it's also against the camera controller. So we'll have an alarm against camera 8, but we'll also have an event that came out of the camera controller. If we look at the alarms, you can see that, camera 8 has had 2 events coming in, and the camera controllers had 4 events coming in over time. So that's fine. If I send in the clear, hopefully these will go away. There we are. So
Okay.
that one's cleared. Yeah, the others are probably cleared eventually. But yeah, the camera controller's going right. Yeah. So that's good.
Wise 4, it records all the history of this morning. Count is 1, 2, 3. You see, count 4 for the clear because of the.
Yeah. Well, that's other. That's just stuff I've done previously when I was testing this out. Okay. Yeah, so you can see the camera controller shared now. It hasn't mapped to camera 8, so there may be something not quite right that I need to worry about. That actually, look, it's the camera motor clear, pan motor clear issue. So I would need to create a second configuration for the clear in order for that to clear as well.
So it didn't correlate.
What it didn't do was create the second event.
It must be something bad. Okay.
It didn't create the second event. If you remember the example that I gave you, I'm only correlating for the pan motor raise, but I'm not doing the pan motor clear. So I need to have a second event spec for the clear, and then it'll work properly.
There is not. Okay.
Yeah. Okay. So I wanted you to see that. Yes.
So regarding those translations, so it is mandatory that cameras should be added into inventory of the system in advance.
Yes, because
you
won't be
cannot
able
map
to do the lookup
to a new non-existing node. Yeah, like provide hard-coded name of the node or something like that.
Well, I mean, it depends how it works. I mean, in this case, I'm doing a lookup based on a known node label. So the node label, I've had to have provision. So I've already had to create a camera 8 in the database for it to be able to do that lookup.
We have no idea how many cameras are behind this controller.
Well, that's a different problem.
Yeah, okay. Life is full
yes,
of problems.
in fact, because it should, we have in some way, Craig, the same problem when we integrate OpenNMS with our solutions, right?
Yeah.
And actually, what I did in order to be dynamic is to be based on sysobject ID. And the mapping of the alarms related to the child class that is in a child class, remaining part. But the main mapping is made by type of device. And then we specify in remaining part of the equivalent of UAI, the name of the equipment or the interface or whatever. So it's not simple to do this. We take it from the message and we put in this string. Whenever you have a hub, you have this kind of problem.
Yeah. Okay. I mean, what you do.
It's not suggestible to know in advance how many nodes are present because that be maintained. This kind of information is quite
well
costly.
I mean, again, you need to provision OpenNMS with the nodes that it's going to monitor. Okay.
But you have to maintain also the provision. I mean, you have
but
to
how are you
know
going
in
to give
advance
the nodes a name? How are you going to give them a name?
The name I take when we integrate with OpenNMS, we take the name in the body of the alarm. We take it and we put in the user reference.
Well, where does that name come from?
The moment it comes from the MIB, for example, sometimes it's present over there.
That only works if the MIB contains the actual name of the device. This is the instance of the device, right? If the device tells you that it's called camera 8, great, that's fantastic. But
not always, of course. Yes. Otherwise, you have to find other methods. But I don't.
That's exactly right.
From my perspective, it's quite costly to know in advance which are the nodes because they can change. You have to
I agree, but the point is that unless you've got that information being sent to you by the equipment, you won't know. Either you've got the IP address of the equipment, or you've got some other bit of information.
But whatever are the messages that are sent to the platform,
Yeah.
Must be an analysis in advance, and then specify which is the method to identify which is the resource alarmed.
Yeah.
So when you find this, whatever is the name, if explicit name or identifier, whatever it is, it has to be catched and translated in another way. That's my approach now.
That's fine. That's good.
Because otherwise it was really is a mess. And
yes.
it works quite easily, because one thing is to introduce another type of equipment, one other thing is to introduce an instance. It's a completely different story.
Right. Okay. So, but I mean, this is talking about OpenNMS, okay? And how you get OpenNMS configured, not how we take that further in terms of integration with Team.
Okay. Good.
Right. I think we've more or less come to the end of our time. We've covered a lot of ground today. I've session 4 we got to, okay, at the end. I still have to do a few notes for session 4 to make it a little bit more easy to follow. But I talked through how the event translator works and talked through how we can translate events. And the use case for this in terms of our cameras was you had a camera controller that sent you a trap, and the trap contained the name of the camera, and we needed to map that onto cameras that were showing up on a map in OpenNMS. So it's quite a good use case to show how you could use this. But are there any just final questions on that?
Craig, is there foreseen a session for polling? No. Or...
Ronnie's going to be doing more on that tomorrow.
Okay, thank you.
So we'll finish for today now, but tomorrow we will be looking at Ronnie. I won't be around tomorrow, to be honest. It'll just be Ronnie. Is going to be looking at continuing on with data collection. He'll cover polling as well, if you make sure you ask him to do that. And then on Friday we are going to just wrap up with a few. To be honest, there'll be miscellaneous different things that either we haven't covered, but it's also an opportunity for you to ask questions. But I would encourage you to finish off session 3 and then go on to session 4, because understanding the event translator and understanding how to parse MIBs is very, very important. And the only way you're going to get to do that is really by practice.
Okay. Thank you.
Thank you.
Last question, sorry, about value type here in translator. So I'm looking down into documentation. Looks like there are only 2 options, as SQL and constant.
Yes.
And that's it. No more other.
No, I believe that's the case.
Okay, thank you.
So you can look up in the database. The truth is that for much more complex translations, you're probably best off using Drools, which is the ready engine to do that. The event translator is good up to a point, but it reaches limitations relatively quickly. The Drools you can use for much more complex event processing if you want to, but that's kind of beyond the scope of what we're going to do in this basic introduction.
Yeah, but rules should be installed on top of the OpenNMS, or it's a part of.
It's part of OpenNMS.
Oh, okay. Thank you.
Yep. I will look at that on Friday, so you at least have an introduction to it.
Thank you.
Bye.
Okay, folks.
Thank you
very much.
Thank you.
And we'll meet again on Friday. Ronnie's here tomorrow. And I will actually try and get this example 4 working a bit better for you, so you can go through that exercise. Thank you. Bye.
Okay, thank you. Bye-bye.
Bye.
Yeah, thanks everyone.
Bye.
Thanks.